Okay, everybody. Thank you for attending today. Welcome to today's session. My name is Josh Brothheim. I'm the training manager at Sumo Logic. I'm based out of the United States. Been with Sumo for about 5 years or now. And what we have for you today are two sessions. We have a morning session and an afternoon session. The morning session, which we're starting right now, is going to be cloud security monitoring and analytics. So what we're going to do is look at the query language and security use cases. So we're going to show you how to create queries that might look for, do threat hunting or look for suspicious logins and similar things like that. In the afternoon, what we'll do is Cloud SIM fundamentals. And so that will be our Cloud SIM product, which we'll get into later. So that's kind of the plan for today. I'm going to go ahead and get started here. I'm going to be handling the chat by myself, so go ahead and put questions, but just might be a little bit delayed. And we're going to take two certifications today, but let's start the morning session. So this is our agenda for today. I'm going to start with an introduction, which I'm kind of doing right now, and then I'm going to do a quick demo. I did a demo yesterday. I'm going to do one today. And then we're going to do labs. So today's class is labs. Yesterday we did some slides, some labs, but today is primarily labs. And then we'll do that certification. So as you had the opportunity yesterday to take that fundamentals exam and hopefully passed it, today we'll be doing the cloud security one. So that's the game plan for today. Let's go ahead and continue here. Now, hopefully you joined us yesterday. If you didn't, that's fine. Today's material builds upon yesterday, but not required. Yesterday was the fundamentals, the basics of Sumo Logic, which are pretty important to understand, pretty important for you to know. Today is now cloud security with the query language. So taking some of the fundamentals, not all of them, but some of them, and using them or building on them today. I showed this slide yesterday. This is Sumo Logic's Continuous Intelligence Platform, or SIP as we refer to it. I'm going to run through it again kind of quickly, just because it's part of my deck. Because also today we're going to focus on a different portion. As a reminder, with SIP, or Continuous Intelligence Platform, you can use Sumo Logic for operational intelligence, security intelligence, which is really what we're going to be doing today, business intelligence, global intelligence. As we talked about yesterday, in order for Sumo Logic to be successful and for you to be successful with Sumo Logic, your data is required. Without your data, there's nothing to do. Sumo Logic requires it. And so your data might exist in many different forms, in many different locations, both physically and in the cloud. As we discussed yesterday, there might be data that's on hosted systems, which are more like cloud environments, AWS, Azure, GCP. You might have data that's sitting on servers, sitting on a server farm, on your laptop, and all that data needs to be collected and brought into Sumo Logic. And once it's in Sumo Logic, then you can start to take advantage of our analytics and start to use some of the advanced analytics that we're going to look at today. Utilize APIs, although we're not going to use APIs today, but other things like that. On the far right, as a reminder, we have our attestations and our certifications. And so we're proud of those. Those are important. They are maybe a little bit US centric, but we are a US based company. But we also have other certifications. So if there's any that you're interested in, we probably have it. And then as a reminder, who can benefit from Sumo Logic? Well, everybody in your organization, regardless of the role. You might be DevOps, you might be engineering, might be many other roles, and Sumo Logic can be helpful to you or for you. Now, specifically want to talk about Sumo Logic in association with security intelligence solutions. And with different security intelligence solutions, we have kind of three of them, three ways that Sumo Logic can help you with security. The first one is, the first one is audit and compliance. And so Sumo Logic can allow you to track what data is being collected, what data is being ingested. There's applications or apps, rather, as we saw yesterday, some compliance apps that allow you to see various audit and compliance related information. And for somebody who's in that role and needs to maintain and understand your environment, Sumo Logic is great. Another use case of Sumo Logic is security analytics, and this is what we're going to be focusing on today, and also what we kind of looked at a little bit yesterday, where we looked at searches, we looked at dashboards, we looked at alerts, and so that's where we're going to be focusing on this morning. Now, in the afternoon, we're going to be focusing on Cloud SIEM, which is another Sumo Logic security intelligence solution. And that one is focused around threat correlation and, as it says there, workflow with event management. And so we'll go through that product essentially this afternoon. But the one we're going to be focusing on today is that security analytics side. And then within there, as we started to see yesterday, you can use Sumo Logic for the searches and the query language. And so we'll do that shortly with the lab. Dashboards are helpful in Sumo Logic so that you can represent your data in a graph or a chart or a map and might be easier for people to understand. And then using the advanced analytics, we used geo lookup yesterday kind of quickly, but we'll use some more today that are helpful. All right. What I want to do now is do a quick demo. And for this demo, it's really more a walkthrough, but let me, here we go, it's right here. So if you remember yesterday when I did my demo of Travel Logic, I had the dashboards that looked well, almost exactly like this, and we went through these. And if you didn't attend yesterday, that's perfectly fine. But we use these dashboards to help understand what was working or what wasn't. The checkout service had errors, and we see that right here in the red. And so that was all very helpful. But this was focused on operational information. What I have here is a different dashboard showing me graphs and charts and maps, but what it is focused around security. And so what we're going to do today is we're going to look at these panels right now, certainly, and actually recreate some of them through lab exercises. So we'll go through a few of these a little bit later, but let's show you what these are. So for example, the first one, and we looked at the mapping capabilities a little bit yesterday, but what we see here with this SSO and non-SSO login location is exactly that, a worldwide map of where our users are logging in from over the last 60 minutes. Now, from a security standpoint, that could be quite important. If we see somebody that's coming from a country that might be security kind of a risk, a country like a Russia or China or North Korea, that is maybe concerning, but certainly something we probably want to know as a security-minded individual. And so this map allows us to see simply where everybody is coming from. Another chart here, right next to it, is this threat intel. And we're going to be talking about threat intel a whole lot today. Threat intelligence. What's occurring here is the system is looking at IP addresses. And over the last 60 minutes, it's found 119 IP addresses. And what it's done with those IP addresses is classified them based on a malicious confidence. High malicious confidence being it's likely to be malicious and bad. Low malicious confidence meaning it's likely to be safe. Now, this is using more than just Sumo Logic to get this information. To get this information of this threat intelligence data, we are associating ourselves with a company called CrowdStrike. And CrowdStrike does a really good job at threat intelligence. That's what their company does, and they do it very well. And we leverage or give you the ability to utilize their data. And that's what we're going to do today later. As we saw with the map data, we can leverage mapping data. We can also leverage this threat intelligence data. And so this is going to allow us to take an IP address and have essentially CrowdStrike look at it and determine, is it a good IP address? Is it a bad IP address? What do I want to do if it's a bad IP address? If it's a bad IP address or a known bad actor, do I want to block that IP address? Do I want to maybe whitelist it and see where it goes and track it? Or, you know, many options there. All right, the next one over here is suspicious login distances. And what this is doing is looking at a user, looking at where they logged in from, and this requires them logging into from logging in, excuse me, from two different places, determining where those places are and how far apart they are, and then letting us know this appears to be a bit suspicious. So what I have here, excuse me, is I have a user Damon. He logged in from the United States, and then in a short period of time, he logged in from Egypt. Now, does this necessarily mean Damon is a bad actor? Maybe, we don't know. It's possible Damon was in the United States, logged in and check his email or do whatever he needs to do, took a flight to Egypt and landed in Cairo and logged in and did some more work. And that explains why the distance is so, a large distance between the two places where he logged in from. Excuse me. And so that might explain it. We also might have the case where we go to Damon or Damon's manager and he says, well, I've been in Paris the whole week. Well, that would be a little weird if he's logging in from the United States and Egypt. And so this can start to tell us that something weird might be going on. Now, this being said, it doesn't really, if you consider VPNs, this example gets a little weird because it's certainly possible Damon is VPN testing and he's testing from all around the world in a matter of seconds. And that's certainly possible, but it brings up the question of what's going on here. And so we would, like I said earlier, kind of maybe go to Damon, go to his manager and mention this and see if there's any abnormal activity. Maybe we get told Damon has been fired already and someone's using his credentials. And so this gives us just a starting point of some odd and peculiar behavior. Right, a couple more charts here. Let's see, this one right here, firewalls, traffic type. We talked a touch about firewalls yesterday. What we see here is bytes sent, bytes received. And so we can get a good feel for, are we getting a much higher one versus the other? Is that a security issue? Are we getting too many bytes received? Are we getting DDoS attacked or something like that? And a really better example of the firewall traffic view is this one of outlier. And we also looked at this yesterday. So as a reminder, what's happening here is the system is looking at traffic volume. It's determining what it considers to be normal. And then these pink triangles are representing the outliers, times where the volume of traffic is abnormal. And so what we're seeing here is over the last 60 minutes, there have been 3 spikes in volume. Once again, does that mean it's a super hacker attacking us? It could, it's very possible, but it may not. And so we still need to do more work to dig in on that. But this is what we're starting to understand from the data. And like I said, what we're going to do is replicate some of these panels, not all of them, through the lab exercises. All right, let's see. Let me go back to my slide deck. And what we're going to do now, let's get into the lab environment. So what we're going to do now is we're going to log into the training environment. These are going to be the same credentials we used yesterday. Not that you need to remember them. If you do, that's fine. But if not, that's okay. I'm going to put them in the chat. And so as a reminder, we're going to go to service.sumologic.com to log in. The account we're going to use is training plus analyst number. So training plus analyst 123, training plus analyst 928, pick a 3-digit number at sumologic.com. And then that password is going to be fireworks ! Once you get logged in like we did yesterday, if you could just type your number just to let me know that you've logged in successfully. If you need help, of course, let me know. But I'll give everybody a few minutes to go ahead and get into Sumo. And for this, we want to use the training account that I provided because we want to utilize the data we have. So you might have your own personal Sumo Logic account or the one you used to take the exam yesterday. We don't want to use that one right now. We want you to use our training account. All right, looks like some of you are starting to log in, which is great to see. I'm going to go ahead and log in as well. So service.sumologic.com. Actually, let me log out. I want to log into the same or similar account you guys are using. So training. I'm just going to wait just a few more moments. All right, so once again, we want to be logged in to Sumo. I'm going to close all these tabs. I don't need them. And what I want to do next is get the labs. So let's go ahead and do that. So what I'm going to do here is I'm going to go into the certification portal. So this is where we went to get the exam yesterday, but we're not going to do the exam. We're going to just get the labs. So what we want to do is we want to go to certification and we want to select get certified. It's going to take a moment to load. And what I want to do is I want to go to recorded live training. When I go to recorded live training, what I'm going to have is a list is a list of all the classes we offer. And you can get the recorded session for each one here. So for example, yesterday we did fundamentals. If you were not able to attend, you can go into the fundamentals button right here, and it will allow you to view the class. But what we want to do for today is we want to go to cloud security monitoring and analytics. So once again, we're in the certification portal. We're in recorded live training. We're in cloud security monitoring and analytics search. We're going to go ahead and register, and this is all for free for you, free for your employer. I'm going to pause this because I don't want to listen to John do my presentation. But what I do want to access here is the student lab guide. So I want to grab that. I'll also go ahead and paste that PDF into the chat, just in case you want to get it that way. But I wanted to show you how to get it, at least so you know for the future. So what I should now have is my lab guide. And logged into Sumo Logic. All right, so I think we're all together, I hope. So yeah, I think we're all good. All right, let me just move this over a little bit. Okay. So assuming we're logged in, we have our PDF, we're going to go through this. So what we have here is we have 8 different labs. Some of the labs are long, so it might not sound like a lot, but it is. And we're just going to go through each one. So the first lab is actually lab 0, which is just logging in, but everybody seems to be okay. And so the first lab, the first real lab, is going to be around monitoring user activity. Now, why do we want to monitor user activity? Well, it's going to help us understand what users are doing. Are they doing things malicious? And so what we're going to do now is we're going to go ahead and create a query. For this example, we're going to be using AWS data, specifically CloudTrail data. And so what we're going to do is we're going to create a query that's going to look for the top 10 AWS activities with user information. As it says here, we're going to utilize CloudTrail logs. And I'm going to go ahead and start to put the query in the into the query screen and go through it. So I'm going to start to work on it. So let me go ahead and just try to get the screen so that here we go. This should be good. So what I'm going to do first is I'm going to go ahead and do a new log search. As we did yesterday, we're going to go to plus new and we're going to go to log search. Now, what I'm going to do next is I'm going to utilize the query that is part of this lab, and this is part of lab 1, step 2. So within that query or within the lab is a query that has 4 lines. And so I'm going to grab those 4 lines. I'm going to paste them in. I'm not going to run them quite yet because I want to explain what they're doing. You might know what they're doing, which is good, but if you don't, and you may not, I want to explain what each one is. What I'm going to do is I'm going to comment off each line, meaning I'm going to put 2 slashes on each line. When I do that, if you notice, the line gets grayed out. And what that grayed out means is the line it's essentially turned off. When I run this query, it's as if those 2nd, 3rd, and 4th lines do not exist, because I want to go line by line and show you what it's doing. So let's look at line 1 first. What's happening here? What we're doing with line 1 is we're looking at source category equals lab/AWS/CloudTrail. And so as we discussed yesterday, we're using that metadata of source category to specify a set of data. We're not using lab Apache Access data today. We're using lab AWS CloudTrail data. And so that's starting to tell us what data we're using. We see that data down below. So down below, we see the log messages, how many there are. And then we see all the different log messages, all the AWS CloudTrail log messages. Now, let's see, just see a question. Good question. The question is, if you notice right here, there's a squiggly, a red with a squiggly mark. And so what that is, it looks like an error. What it is very simply, it's really Grammarly, actually, I think, is doing it. So it's just the system, like a spell checker, doing it. It's not actually Sumo Logic syntax. So let's go ahead and run this first line. You don't have Grammarly. It shouldn't be. Let's see. I don't know why it's shown up there. I'll have to take a look at that. So what we're going to do with this data is, when we looked at the data yesterday, we parsed out our data. And what we're doing now is a similar thing, except the data is a little bit different. If you remember yesterday, the data was just long lines of log messages. And what I have here is a log message. And within this log message, I have fields and I have values. So here, for example, is a field. This is AWS data. So there's going to be a field for AWS region. There's a value for AWS regions. Here it's US West 1. Here's the field for source IP address, and here's that value. So what I'm going to do is I'm going to take some of these fields that exist within this log message and parse them out. Yesterday, I did parsing, and it actually has it in the lab guide where we can parse using the UI, where we highlight it and right-click on it. But in this case, I can do something easier. Since these messages are in a JSON format, I can go ahead and utilize, basically the system knows how to read JSON and recognizes those things as fields. So what I'm doing is I'm taking the field of user identity, dot username, so essentially this field, and I'm going to call it actor. When I run this now, the system is going to look for that user identity dot username field, If it finds it, or rather when it finds it, it's then going to pull that value out. So now I'm starting to see the users that were starting to do activities within AWS. Here, Kevin did something. Here, Ankit did something. Ankit did something else. Suraj did something, and so on and so forth. Now I'm going to take this further because remember, we wanted to look at these activities. We want to see what users were doing. So what I'm going to look at next is what's called the event type. In this case, I'm going to take the field called event type, and I'm going to actually just rename it to call it event underscore type, just because I want to, really. When I do this now, I'm now going to have a new field called event type, and I'm going to have that event type. It's very simply just taking this event type right here and parsing it out as a field. So now I can see Kevin did an AWS API call. Goja did an AWS API call. Kevin did an AWS console sign-in, and so on. Now, the last thing I'm going to do here is I'm going to extract or parse out the IP address. Same idea, taking that source IP address field, identifying it, and then extracting or parsing the value associated with it. So now I can see Ankit did the AWS API call from this IP address. Kevin did the AWS console sign-in from this IP address. And now I'm starting to get information from my CloudTrail logs. Now this next line, and this is step 6 in the lab, is going to be adding a line that is a little bit strange. This line is where event type matches event type. And so it looks to be exactly the same, and it is exactly the same. It's not, there's no trick here. What I want to do is I want to add this. And what I want to do next is I want to turn this event type into a parameter, which allows me to toggle or select a value of the event type I want to choose. I want to essentially pre-populate a list. So what I'm going to do this is I'm going to highlight the word event type. And if you notice, before I highlight it, if I look at the bottom right of the screen, kind of bottom right, or let me show you what occurs when I do highlight it. When I highlight it, I have this option over here that says create a parameter from the selected text. When I don't highlight it, I don't have that option. And so I want to take advantage or use that option. So I want to highlight the event underscore type, and I want to select create a parameter. When I do, I can now describe or fill in the blanks or label this this parameter. I don't need to do too much to the screen. The only thing I'm going to do here is for the parameter name is I'm going to call it event underscore type. And now that I've had that entered, I'm now going to click save. When I click save, you'll notice I now have a box up here called event type. What I can do is I can now enter a value in here. So for example, if I just wanted to look at the AWS console sign-ins, I could just put that in. And now it's acting as a filter for me. Now I do need to make sure something is in here. I can't leave it blank. So I want to enter a star or a wildcard where I'm saying grab every event type. And so that's hopefully where we're up to right now after about step 10, 9 or 10. Now, the next portion we're going to do is we're going to add 3 lines that are a part of lab 12. Actually, 4 lines. All right, so let's go through these lines. So the first line, well, not the first line, but the first line we're adding here is very similar to the other one, except it's actor or user. So what I need to do here is I could specify a user, or I want to go ahead and put a wildcard so that I get all the values. We're creating a filter, but we don't want to use the filter yet. Now I want to go ahead and start to aggregate my data. To add a line to a query, you want to do a shift enter or an alt enter. That should add a new line. So now we're going to go ahead and start to count our data. Remember, we're taking all these AWS activities and we want to see who is doing the most of them. And so we have all the data here, but now we need to start aggregating it together. So in line 7, I'm going to count my data. I'm going to count the actor. I'm going to count the event types. I'm going to count the event names. Since I'm counting it, I get this aggregates tab, and now I'm starting to see this user did this many times. Now, this is good, but this list has 17 things on it. I want to keep it to the top 10. And so I can go ahead, and that's what I'm going to do in line 8, is look at the top. Top is an operator. I can look at the top 5, the top 50, the top 7. In this case, I'm going to do top 10. I want to look at the top 10 actors or the top 10 users by what they did and how many they did of it. Essentially, rank them. So now if I search, I now start to see who was doing the most things. Kevin was doing a lot of AWS API calls. What I'm going to do next is I'm going to use the transpose operator. And we looked at this yesterday. And what it's going to do is just take this data and just format it a little bit better. It's now going to take the actor or the user and make that a column with, well, a row, I guess. And then we have 2 columns for our different event types. And so now I can more easily see, here's what's been happening over the last 15 minutes and who's been doing it most frequently. And that was the goal of this lab, was to start to look at AWS activity usage. So let's see, let me just see. I think we're done with that lab. Oh, no, that's right. This lab goes long. What we want to do next is we want to turn this into a chart. So as we discussed yesterday, when we go into the aggregates view, by default, we're in a tabular or table view, but we can look at this data in a bar chart, a line chart, pie chart, whatever is appropriate. I'll keep the bar chart. I can go ahead and modify the colors. So I can go to this gear icon and start to change the properties, change the colors. Now, the next thing we want to do, this is going to be part of lab, this is still the first lab, but step 18. So hopefully we're all together. Certainly let me know if you're not, but at this point we should now have created our AWS activity query. We should have modified it to look like mine does. We should have our parameters and we should have our chart. So that's where we're at right now. What we want to do next is we want to utilize a lookup table. As a reminder, up here with these event types and these actors, these are fill in the blanks. Or I don't know if fill in the blank is the proper way to say it. I can type anything in there. So if I want to look for a specific actor, I need to know who that actor is. I know there's an actor called Kevin, and so I can just type in the word Kevin. And when I do, I now see Kevin's stuff. But what if I want to look for somebody else's stuff? I don't remember what other names there were there. So what I want to do is utilize a lookup table. And so let's go ahead and set that up. And this is going to be step 18 in the lab guide. What I'm going to do first is I'm going to go to my event type. I'm going to click on the 3 dots, and I'm going to go manage parameter settings. It's going to take me to a screen that I kind of saw earlier, but it's similar. What I want to do is I want to go down to this portion here where it says set values for parameter. I can decide how I want to set those values for the parameter. In this case, and most common, well, yeah, I guess most common would be lookup. And what I'm going to do now is I'm going to reference a lookup file, a file that I or somebody in my training organization that may have created. And so the lookup file is located at shared/event types. And as you see, the search ahead works for me here. Once I've entered that lookup file name, I need to specify the field that I want to pull or extract from that lookup table. And that field is also called event type. And once I'm done, I'll click save. So I just want to leave it on the screen for a moment, just for everybody to see. So we went in here, we added the set value for parameters, did the lookup, entered the field type, the field lookup file and the event type, and then now we can click save. And if I did everything correctly, when I rerun my search, I now should be able to go to my event type, delete what's in there, and now I get a pick list. And so now I can say, just show me AWS console sign in. And now I'm just interacting with my filter or well, it's a filter, but the parameter option. All right, so hopefully we're up to that step. We're still more to this lab. This first one's a long, very long lab. So what we're going to do next is, now that we have our chart, we have our parameters set up, we're now going to add this panel to a dashboard. And so what we're going to do is create a dashboard. We did this yesterday, and as a reminder, it's pretty simple. We're just going to go ahead and click Add to Dashboard. We're going to give the panel a name. So as mentioned yesterday, something that's sort of descriptive. And then we're going to save it to a location. For today, we want you to, as it says in the lab guide, use the name of SOC, SOC, underscore your initials, and then your number. Doesn't have to be exactly like that, but something similar, just so that you can recognize it. Once I have that entered, I'm going to go ahead and click Create New Dashboard. And for this example, and for today, yeah, for most of today, we're going to use the old dashboard style. So we're going to want to go ahead and click and turn this off. Some of these labs, they just need to be updated for the new dashboards, and I haven't had a chance to. So once I have that all together, now I'm going to click Add. And what I should have here is now my panel and my dashboard. Now, the other thing I can do in here is I can go to the filter, and I can use these filters that I just created. If I want to now look for a specific user, I can do so. I can also look at, let me just put it back to the way I had it first. So I can look at the filter for all linked panels, or I can look at a filter for a specific panel. And as we start to add new panels to here, we can do so, either looking at filters through many different panels at the same time or individually. And so we'll talk about that as we get further. All right, let's see, that should conclude lab one. So lab one is, quite a long lab, but hopefully you got through it, and yeah, hopefully you got through it. All right, so let's go in and start lab two. Lab 2 is going to be geolocation. We looked at some of this yesterday, but we're going to get a little bit more in depth. And so what we want to look at with Lab 2 is, as it says there, geolocation of console logins. Where are people logging in from? What IP addresses? And more specifically, where in the world are they logging in from? So that's the goal here. What we're going to do is, once again, do a new query. And now what I'm going to do is, like I was doing earlier, is basically grab the query and paste it into the query screen. So I'm going to go to lab 2, step 2. I'm going to grab that query. I'm going to let's see. Let me go ahead and turn these off. So I apologize if I'm going a little too fast. You're welcome to go back to these labs at any time. So if you want to sit and watch me do these labs and then do them yourself later, that's good. It's a very good idea. But hopefully you're able to get the concept. So, but we, yeah, just want everybody to hopefully pick up some knowledge from today. What we're doing for this lab is, remember, we're looking at where users have logged in from. So we're still going to look at our CloudTrail data. We're still going to go ahead and look for those users, those usernames. We're going to go ahead and look for those event types. What was the user doing? Were they doing those AWS API calls or not? We're going to need the source IP address. This IP address is going to be crucial for us to get geographic information. And then we're going to get one more field here. The field we're going to pull is console login. And what we can do is we can see, did the person log in successfully or not? This lab is about seeing where or how many people where and how many people logged in successfully. And so this console login, the status of it being successful is important. And so that's why we want to pull it. The next portion of this lab is going to have two is empty lines. What we're doing with these is empty lines is we're saying, look for the actor or look for the user, look for the event type. If the user is empty and we have a not symbol, meaning if the user is not empty, don't include it. Basically, I only want to include data that has results, and that's what this is doing. If there's no actor in the log message, it won't include the result. If there's no event type in the log message, it won't include the result. And so this is a way for me to sanitize my data in a way and say, don't include these things. Like we did yesterday where we excluded the 200s, 304s. This is a way for us to say, don't include anything that's blank because we only want things that have value. Now we're going to go ahead and add the two parameter lines. So we're going to add the where event type matches event type, where the actor matches actor. And once again, we're going to want to put in stars or wildcards or asterisks for those values. And so what I should now have is at the end of lab 2, step 6, is I should now have the log messages of who logged in, what were they doing or where did they log into? Did they log in successfully? And what IP address did they log in from? Now I need to bring in the geographic information. And so what we're going to do is we're going to use a lookup for this. I started to talk about this a little bit yesterday. Going to go, of course, more in depth right now. But let's go ahead and grab the query. So what we want to do is we want to add just one single line here. That's in step 7. That looks like this. sorry, just let me make this a little bit, that should be good. And so what we want to do is we want to add this line that's in the step 10 or line 10, excuse me. And this is going to be used to look up the geographic information. This line reads, if we read it, we want to read it from right to left. Of course, in English, we read things left to right. But this line, if you read it from right to left, I think it's going to be more helpful. What we're going to do here is we're going to take the source IP. So each log message has an IP address or a source IP. And what we're going to do is we're going to take that source IP and we're going to compare it to the IP that exists in the geolocation lookup table. And so this is a lookup table that has geographic information in it. Once we get that information, or once we view that information, if the IP address is there, we're going to look at this geographic information. We're going to extract the latitude, the longitude, the country name, the city, the region. So let's take a look at what that looks like. So I'm going to go ahead and click search. And now what I see, for example, in this first IP address, I see the IP address and I see the system has found this IP address to be within China. This next IP address down here is Venezuela. This next IP address is Malta, and so on. What I'm going to do next is I want to count my data. I now have my data in a list, but I just have my raw data. What I need here is the data to be aggregated. Also, there's a question about the geolocation. What this is it's it's like a Sumo Logic service. Essentially, we have a table of geographic data located in this spot. We'll take a look later, or in a few moments, when we get to CrowdStrike at another location. So it's yeah, I guess you could call this service. What we need to do is we need to count this data. Sorry, it just didn't paste very nicely. There we go. So what I'm going to do is I'm going to count this data. By counting it, I now get my aggregates tab. Once I have my aggregates tab, as a reminder, I can look at this data in other views. I showed you the bar charts and things like that. But what I have now is a new option, which is the map icon. The reason I can use the map icon right now is because I have a latitude and longitude. So the system is going to take each one of these latitudes and longitudes and plot them on a map. And now when I click on the map icon, might take a moment, but now I start to see where my users are logging in from. And so once again, from a security standpoint, this could be quite helpful. Should users be logging in from China? Depends on countries and politics and things like that, but that might be helpful to you. Okay, let's see, let's continue. One other thing I want to show, let me just, because just about the geo lookup. I'm just going to put a link to the help article to provide you just some more detail about it. So let me just put that in the chat. Okay, cool. All right, let me go back to the lab guide, or back to, back to the lab guide. So what I want to do now is I want to take this panel and add it to my dashboard that I was building earlier. So I'm going to go ahead and go add to dashboard. I'm going to give this a name. I'm just going to call it map. I'm going to go ahead and find my dashboard. So as I was using the dashboard called SOC_JB234. And I'm going to click add. Now here, I'm going to go ahead and add this panel. What it's letting me know is it's letting me know in my dashboard that I'm about to go to, I have filters that already exist called event type and actor. And it's letting me know that conflict. I want that, the conflict is okay because I want to use that filter again, but it's letting me know if I did not intend to, I could modify it or change it here. So I'm going to go ahead and click add panel. And what it's now going to do is it's now going to show me both panels in there. And now I can go ahead and use my filter up above across all these panels or both of them. So if I wanted to now see where Kevin, I just wanted to look at data for Kevin, I now see only his user activity, and I see only where he logged in around the world. Let me go ahead and put that back. All right, and that should, yeah, that concludes that lab. All right, we'll go ahead and do, let's do the next lab. We'll do one more lab and then probably take a break. So lab 3, what we want to look at is failed login attempts. Why are failed login attempts important in a security use case? Well, I think that's kind of obvious. It could be a sign of a hacker. It could be somebody trying to do a brute force attack. It could just be somebody that forgot their password. But what we want to do is we want to look at that data and look at it through Sumo Logic. So we're going to go ahead and create a query. The query that we're going to use is sort of repetitive to what we've been doing. So this is going to be lab 3, step 3. And grab all those lines within that query. Do a new log search. Paste it in. And once again, run it. And so once again, I'm looking through my need an underscore at the beginning of source category. And need a space right there. So once again, as I've been doing, I'm now grabbing my logs. I'm grabbing the user, what IP address they logged in from. Did they log in successfully? And I'm also going to add in those parameters. So I'm going to go ahead in step 5 of lab 3. And once again, with this parameter, I need to put a wildcard in here or an asterisk to represent the fact that I'm putting that there is a value in there. And once again, in in step 7, actually, there's a few different things here. Let's go ahead and grab all of them. So in step 7, I'm adding a few different lines. Some of them we've looked at already, but one of them we haven't. So the first 2 lines here we added earlier. So we're saying only show us where there is an actor and there is an event type. What we're doing here is we're saying only look where the result equals failure. And what that is referring to is this result right here. For this lab, we do not want to look for successful logins. For this lab, we do not care that somebody logged in successfully. What we do care about is somebody that did not log in successfully. So that's what we only want to look for. We only want to see where the result equals failure. And so when I run this, all those successes are gone. And actually, I might want to choose a better time period. And so what I'm now seeing is, for example, over the last 60 minutes, how many people could not log in. Now, the last line in this is in line 12. I'm going to say just look for AWS console sign-ins, because in this case, I just want to see, did somebody sign in successfully to the console? And so I'm using these filters to limit my result set. I don't want to look at all data. I want to look at just those things that are important to me. All right, what we're going to do now is we're going to go ahead and add a time element in here. So for this one, I'm going to modify my query in a couple ways. The first thing I'm going to do is I'm going to look at the last 24 hours. Let me just run that. Last 24 hours. I just want to make sure I get my data back. Okay, good. So what I'm going to do here is I'm now going to go ahead and start to utilize my time slice. Is it still loading? What's it doing? It's still loading, but that's okay. What I want to do is I want to introduce my time slice because I'm looking at my data over the last 24 hours. But what I want to do is I want to look for a specific, not a specific, but I want to look at my data in a 1 hour quantity. We used a 1 minute quantity yesterday, which allowed us to look at data not from 8 o'clock to 9 o'clock, but 8:01 to 8:02, 8:02 to 8:03, 8:03 to 8:04. Here, we're going to use a 1 hour time slice. And so what we're going to look at is data over the last 24 hours, but in a 1 hour period from 10:30 to 11:30, from 11:30 to 12:30, 12:30 to 1:30, and so on and so forth. So what we're going to do, and this is part of step 9, is add that time slice. Actually, we're going to add 3 lines here. Let me just grab them. So I'm doing a shift enter. I'm now going to paste these 3 lines in. So when I run this, I'm going to have my data broken out into 1 hour buckets or chunks of data. And then I'm going to count that data. And I'm going to count it by the time slice, as well as the actor and the event. What I'm now starting to see is during a 1 hour period, how many times were users not able to log in successfully? So for example, here from 10 a.m. to 11 a.m., Jay Schmo was not able to log in once. Ankit was not able to log in once. What I want to do next, though, because I see some users were not able to log in twice during a 1 hour time period, I am going to go ahead and now say, show me the top users, the top 10 actors. Who could not log in the most frequently? And now I'm starting to see that. It should, let's see, it's going to still going, but it's just about done. Now I could sort this. I'm going to just click on the column to sort it manually. But now what I'm starting to see is during all the 1 hour periods, Ankit from 8 to 9 p.m. was unable to log in 3 times. Kevin was unable to log in twice. Now these numbers are kind of low. What we're going to look at, and actually it's going to be an example in a few moments, is a brute force attack that might be representative of someone trying to log in multiple times. But that's what we're starting to see here. Now, what if we wanted to look at this time slice in a more frequent group? We could look at this in a 5-minute time slice. We don't have much data here, so a smaller time slice won't be as helpful, but we could go ahead and start to look at it in different groupings of time. I'm going to go ahead and now add this to the dashboard. So once again, we now have a new panel that we can add called failed logins. And we're going to add that to our SOC dashboard. Come on. There we go. And now we'll add it to our dashboard. And we'll get that warning again, and that warning is okay. And now we have 3 panels here. All right, let's we might do one more lab here. Let's see. Yeah, let's run through lab 4 not very quickly, but we'll go through lab 4 and yeah, let's do that. It's also similar to the one that we did earlier. There was a question, can you do a sort by? Absolutely. I just, let's see, we'll do a sort by, I think, pretty soon. So yes. What I want to look at now is, this is going to be lab 4. And what we're going to look at is the idea of a brute force attack. What a brute force attack is a large number of attempts to log in, where a user will essentially have an account and try many different passwords and keep trying until they find the right one. What we're going to do now is we're going to look at our CloudTrail data and detect, are there brute force attempts possibly happening? Do we see a large number of failed login attempts during a period of time? Now we're going to look at this. The data we have is not great. I don't have an example of a brute force attack within our data, so we're actually not going to find one, but we can still go through the steps and look at a query that would find one if one existed. So it's still a helpful lab. It's just we're not going to find the result that really would be good, but it's okay. It's still good exercise. So this is going to be lab 4. The first 5 or so lines are pretty much identical to what we've been doing earlier. So once again, we're going to do that new search, new log search. We're going to do that query. And we're going to go ahead and grab, once again, the CloudTrail data. And I forgot my underscore. We're going to grab the actor, the username, the IP address. So all that information, getting a little repetitive, but that's okay. I'm going to go ahead and once again add my parameters in, so that where event type matches event type, and where the actor matches the actor. And I'm going to put those asterisks in there. Now in step 7, this is where we're going to start to look at the occurrences of logins, or the type of logins. So let me go ahead and paste that in. All right, so what I'm doing here is I'm once again, let me do the last 24 hours. Once again, I'm using my time slice. Now I could do this in a time slice of a minute, an hour, but in this case, I'm going to use that hour. Now what I'm going to look at is the result. Did somebody log in successfully or not? And what this is a tally system. So if a user logged in successfully, there's now going to be a new column called success count. And there's either going to be a value of a 1 or 0 based on a true or a false of if the result equals success. So let me show it because it's a little hard to describe. So the system is going to look at the result. It's going to see, is it a success or a failure? If it is a success, it's going to tally a 1 in the success count. Just want to see if I have a failure here. Sorry, I just was hoping to show what a different one looked like. All right, well, that's okay. Now I'm going to do the same thing or similar thing with this line 11, where I'm going to look for a failure. And if I find a failure, I'm going to tally a 1 in a failure count column. So what I'm now doing is I'm creating 2 columns, a success count column and a failure count column. There's either going to be a 1 in the success count or a 1 in the failure count for each log message. And what I'm going to do now is I'm now going to take those successes, take those failures, and add them up. And I'm going to do it by the time slice, by the actor, and the event type. And what I'm now starting to see is Ankit from 11 to 12 p.m. logged in successfully 52 times and failed to log in once. Suraj here logged in successfully every time. He never failed to log in. Now, to order it, I could go ahead and click on the actor. The other thing I can do is sort by actor. So now I start to have my actors built in there. Now, we still have a little bit more to do with this lab. But where this is not going to be a great example is we should have, this would be better if we had a lot of failures. Unfortunately, we don't. What we have here is people logging in successfully, which is good. But if we had a lot of failures, that would be better for this example. That being said, let's still go through the example because there's still helpful stuff in here. What I want to do next, and this is step 8, is I want to create a failure percentage. What I want to do first is I want to say, only show me where there are failures. So for example, in this line right here, I know this is not possibly, for this example, this is not a brute force attack because I want to look at failures. This is all successes. So it doesn't fall under the brute force attack framework of what I'm interested in looking at. This still could be malicious. This still could be a hacker who knows the password, but that hacker logged in successfully every time. What I'm doing with here in line 15 is I'm now saying, take the failure, take the success, multiply them by 100, and essentially giving myself or giving these users a failure percentage. And what I could now start to say is this user had a low failure percentage. He logged in out of 100 times, he logged in 99 successfully. Versus this person down here logged in only 5 times and failed to log in once. And so their percentage of failure to log in is 20%. And so now we're starting to be able to find this. Now, once again, if a better example of a brute force attack would be a failure percent of like 99%. But this is what the data shows us, and this is what we can do with the data. Once we're done here, we now have this failure percentage rate dashboard, and now we can add the dashboard to the panel that we've been working on. So failure rate, and then I'll add it to my dashboard. When I add it, I'll get that warning. And then once it finally loads, there we go. Now I'm starting to see those percentages. All right, let's take a break. We're doing good. Doing well rather. So let's do it. We'll do a 10-minute break. I'll put myself on mute. I'll get a snack or a beverage. Encourage you to do the same, and then we'll come back and do more. So let me go ahead. Let me just get this started real fast. All right, very good. Enjoy your break. All right, everybody, welcome back. Let's go ahead and let's continue. So we're going to go ahead and get back into our lab guide. And what we're going to do is work on lab 5. So with lab 5, what we're going to be doing, lab 5 is, well, they're all involved. Lab 5 is about land speed violations. And so I showed this earlier where we saw a user that had logged in from Egypt. They logged in from the United States. Those two places are very far away from one another. And so that's odd behavior. What we're now going to do is look for a land speed violation. What we're going to look for is when a user logs in from one location and logs in from another. So this requires somebody to log in twice. We're going to see where they logged in from using the geo lookup operators that we were using earlier. We're going to see when they logged in, what times did they log in from two different places. And then what we're going to do is determine, is it possible for them to have traveled fast enough to get from one place to another? So if somebody was in the United States and Egypt, and they logged in during a 24-hour period, that is possible. If somebody logged in from the United States and Egypt during a 10-minute period, that's not possible. And so this query is going to allow us to look at that. This is not a query that you'll use frequently, but the ideas in here I think are helpful. And so I want to go through it. Some of this gets very just overly complicated. And so we're going to skip through, we're going to go through the whole query, but we're going to skip through a little piece of it here and there. So it's not important that we understand every detail for this query, just at a larger or higher level what it's doing. So let's take a look together. And what we're going to do here is essentially go through a query that does everything in this chart. And this chart is busy, there's a lot going on, but what we're essentially going to do is look at a source category, look at a user and an IP address, filter out blank or null IP addresses. We only want to look for good IP addresses. And then we're going to go ahead and have the system create essentially a time zero or a starting point for when a user logged in. We're going to filter out single logins. For this exercise, we care only if somebody is logged in twice during our time period. If they logged in one time, that's not helpful here. We're looking for somebody that has logged in twice, and then as a result, where they logged in from. We're going to go ahead and take our IPs, and we actually have to convert them to a decimal format and back. It's just not an unnecessary step, but we'll go through it. It's not something you'll do often. We'll take the IP addresses and do the geo lookup. We'll then calculate the distance between the two locations. We'll then calculate the speed that a user would have had to travel in order to log in from those locations. And then we're going to specify a speed that is impossible to go faster than. And then we're going to format it. So lots of steps in here, but let's go through some of them. So let me go ahead and first in step 2 is the source category and the username. So in line 2, what I'm doing is I'm actually extracting 2 different fields here. If you remember earlier, I was creating a JSON line to extract one field and then a JSON line to extract another. I can actually do 2 at the same time. Many ways to parse. I've mentioned this a few times, and there's just a lot of ways to do it. Where'd my lab guide go? Sorry, let me just move this all around. Now, the next thing I want to do here, and it's a whole bunch of lines. I don't want to go through each line. Well, I'll go through it in detail, but I don't want too many questions about it. What we're doing here is essentially we're saying, look for the user or the actor, look for the IP address, and only look for public IP addresses. If an IP address is a private IP address, we can't do any geographic association with it. So we want to look at just IP addresses, public IP addresses. Here, we're starting a clock. We're saying, okay, this person logged in at this time. What we're going to do shortly is see, okay, they logged in at this other time and start to look at the times between the two logins. But we're not there yet. So at this point, we have users, we have IP addresses, and we have login times. This next portion, it gets kind of in the weeds, but what we're going to do here is we wanted to go ahead and take our IP address and turn it into a number. And so we can go ahead and use an IPv4 to number filter or operator, excuse me, to do so. So we're taking our IP address and turning it into a decimal. And what we're doing here is we're actually taking it and converting it back. And these steps are really just, it's really just associated with this lab. This is nothing you'll probably ever do again. But I still want to show it. Let me just clean this up. So what I have here is, and what I really want to show is the idea that I have my user. I have the IP address that he logged in from first. And then I have the other IP address that he logged in from. Now I'm going to use the geo lookup. I'm now going to say, look at the IP address, look at the other IP address, and tell me where those are. Give me that geographic information. Look for one and call it essentially location 1, and then look for location 2. So now I start to see over here my lat1 long 1 and my lat2 long 2. So I'm now starting to see where somebody logged in from. So I'm getting that geographic information. Now this next thing, this is a feature. Yeah, this is something you will not use on a regular basis. It's a really neat feature, but it's not a commonly used one. What we want to do now is we now know where somebody logged in from around the world. We know they logged in from Ireland, and we know they logged in from South Korea. What we need to do next is calculate the distance between those two locations. Remember, the world is a globe or a sphere or a circle, and so we have to calculate for that. We can do so using something called a Haversine formula. This is not a Sumo Logic thing. This is a math thing. But what this allows us to do is look at two different latitudes and longitudes and show us in kilometers how far apart they are. And so when I run this last line, this line 26, what I'm now starting to see here is here's somebody logged in from the United States. Here they logged in from Brazil. Those are 7,000 kilometers away from one another. Now, once again, it's possible that somebody could have logged in from the United States and Brazil during a 24-hour period. So we know the distance, but now we need to start to add the time component to start to understand how quickly they would have had to travel in order to do so successfully. So back to my lab guide. And what we're going to do here is we're going to calculate the speed that a user would have had to travel. So if they did so here we have somebody logged in from Japan, logged in from the United States, 10,000 kilometers away from one another. The login delta that we see here is 0.0001 hours, meaning essentially somebody logged in from the United States and then a few seconds later they logged in from Japan. Now, the only way that would be possible physically is if they were able to travel over 8 million kilometers per hour. Now, that's not possible. Kind of obvious, you can't travel 8 million kilometers per hour. And so we can now have our system, our query filter for that and say, and this is going to be step 9, it's only possible to travel 500 kilometers an hour. Anything more than that is impossible. So only show me where the apparent velocity kilometers per an hour is greater than my 500 kilometers. Essentially, only show me those times where it would be impossible to actually travel that fast. And that's what I'm left with. I'm now left with these examples of users that have logged in from Argentina, logged in from the United States. And unless they were able to travel really, really fast, they would not physically be able to log in from 2 different places at the same time. Now, the rest of this query is just a lot of cleanup, which is helpful. The cleanup is good. What it allows us to do is take our mess down below and essentially clean it up. This fields this allows us to specify what fields do we want to display. I have a lot of fields down here, and a lot of them aren't really necessary anymore. And so to clean it up, I can say, just show me the fields of user, IP address, etc. And now when I clean all this up, that. Now I get something that's at least easier to understand. Here I see Kevin. He logged in from Turkey. He logged in from Australia. Those are 14,000 miles away from each other. He logged in basically at the same time, and so he would not physically be able to do so. All right. So this lab is a lot. it's quite a full lab, and a lot of it, a lot of these operators you just don't use much. It's really a one-off, but I did want to show it because I think it's kind of neat and helpful. Yeah, I do think it's helpful. Just it's a bit of a one-off use case. And what I'm going to do now is, like I've been doing earlier, now I'm going to take this, add to my dashboard. I'll call it just distances. And now I have this one added, or I do in a moment. Now I have it. All right. What we're going to do next is we're going to do lab 6. And what lab 6 is going to do is some more work with the lookup tables. So let's do it. So with lab 6, what I want to do is I want to go ahead and do a new log search like I've been doing. And let me go ahead and show you how we're going to create this lookup table. So we're about to add a lookup table that we can use use wherever we want it to. So let me go ahead and let me just paste all this in. It's got formatted a little bit weird here. Let's see. Okay. Just one more second here. All right, and let me come. Okay. So what we want to do now is we want to create a list of users, a list of actors, and we want to create it as a lookup table that we can reference. So as we did earlier when we did so for the parameters, we could do so for our users. So the first thing we want to do is we want to look at our CloudTrail data. And I'll expand this out. But we want to look at our CloudTrail data because that's going to show login information. We then want to go ahead and look for the user name or the actor. So once I run this in line 2, it's going to give me now for each log message, the user or the actor. Remember, my goal here is to get a list of users. What I'm going to do next is count by those users or count by those actors. I'm going to take all those actors and add them up and tally them. And so I see all the different users here. And a user or an actor could be a machine, service, or system role. So it might not actually be a physical person, but these are all the accounts we're seeing in here. Now, for all these accounts, I see the actual count of how many times the user has showed up. And I don't really care how many times the user has showed up. I'm trying to create a lookup table of all the users. I don't care if a user showed up once or 100 times. As long as they showed up once, that means they're a user. And so what I'm doing in this fourth line is I'm saying remove the fields of count. Fields is an operator, and I'm doing a minus of underscore count. I'm basically removing the count column. And now what I have left is a list of users. Now what I'm going to do is save that list of users. And to save it, I'm going to go ahead and save shared. And I'm going to call this, I'm going to call this JB234. I'm going to just add a few more numbers just because I think I might have one saved already. Let me just save, copy this. And what's going to happen when I click search or start right now is that it's going to run and it's going to ask me, do I want to run this query? Essentially, do I want to save this data? And I'm going to click yes or run. And what should now happen is I now should have a lookup table available. Now what I want to do is look up that lookup table. What I'm going to do is I'm going to do a new query, and I'm going to do a cat space the name of that lookup table. So when I run this, what should happen is I should get my lookup table. Now this is saved to a shared environment. I'll go ahead and put it in the chat. You should be able to look at my lookup table that I just pasted into the chat. Technically, if you send me yours, I should be able to look at yours because it's shared. And so now we have our own lookup table of users or actors. What we're going to do next is we're now going to associate that with the user or the actor within our the dashboard that we've been creating already. So what we're going to do now is we're going to go into the dashboard. We're going to go, for right now, it doesn't really matter which one we go to. Yeah, we can go to any of them. I'm going to click on this icon that says show and search because I want to see the search query that was used to create any of these. Oh, yeah, it really doesn't matter which one I use. And what I'm going to do here is I'm now going to go to my parameter, and I'm going to go to manage parameter settings. And now I'm going to specify, like I did earlier, I'm going to set the values for parameter. I'm going to select the format type of lookup. And I'm now going to specify where my lookup table is. And then I'm going to select actor. So I went into the parameter settings for the actor. I added the format of lookup. I added the lookup file location. You can use mine or you have your own shared that you might have just created. And then I specify the field of actor. When I click save now, now if I go to my actor field, now I have a pick list of all those actors, all those users. Now, as it says in the lab, we would need to redo this step for each panel if we wanted to make it so that we could filter, use the filter for all of them. Should show up in there. Why didn't just save it right there? I just went through the steps and that's weird, but no big deal. But hopefully you saw that. All right. Now this next lab, I'm not going to go. I'll show you it. I'm not going to go too detailed on it. Let's see. Look up. So a good question. So the question is, lookup tables are not universal. That's not true. So it depends if you use the /shared or not. So they're specific to an account, not. And when we say so, when I say universal, I mean for the dash. Correct. So so the question is, they're not universal for up here. We can configure them. Not right there, but we can do so, but by default, they're not. So if we wanted to, we would actually go to each one, link it, and then when we go up here to this filter, then it should inherit that actor and allow us to use it. Good, very good question. All right, lab 7. Oh, wait. Lab 7 is all about exporting this dashboard. So I don't know that we need to actually go through these steps necessarily, although you're welcome to, of course. But the idea is we've now created a dashboard that is hopefully helpful. It's now, showing us this graph and this chart and this map and all this good stuff. The idea is that you could actually take this dashboard and export it and import it into your production Sumo Logic environment and actually utilize it. Now, the one thing you would really need to change is the source category. Assuming, of course, you have CloudTrail data. But if you had CloudTrail data in your own production environment, you could take this query and take the whole dashboard and paste it in and just modify this to be specific to your environment. Another reason, not a reason, but another helpful thing, and I think I mentioned this yesterday about these dashboards, is they are in a JSON format. Or not a JSON format. Yeah, it can be exported into JSON. And so you can utilize that raw JSON to edit your data. And so what we would have you do here, and like I said, I'm not going to go through it just to save a little bit of time, is the idea that we could export this JSON. We could import this JSON into a text editor. We could take that text editor and modify the source category to be specific to the source category that's appropriate for our data. And then we could import that JSON. And so that's what this exercise is all about. But I don't think we're going to do it right now. Just, no reason to. But this is another example of, if you come back to these labs later, maybe you do want to take this a step further. As a reminder, you'll have access to this training material really as long as you need. Yeah, you'll be able to access this indefinitely. So you can always come back to this information. All right, let's go to, I think lab 8 is the last one. Let me just see, yeah. Now, lab 8 is going to show a few different concepts. The real important concept I want to show here is the threat intelligence. Oh, let's see a couple questions. Interesting question. Is it possible to parameterize the source category? Yeah, oh, absolutely you can. So the question is essentially, can you take this source category and turn it into a parameter? And you can. As you see, I'm kind of starting to right now. So absolutely you could do so. And then you could have that list of source categories, kind of like we pulled yesterday, and you could just save that into a lookup file like we were starting to do, and then have that pre-populated. So yes, good example of usage. But that's not what we want to do. So let's see, what are we up to? We're up to this lab. And so with lab 8, what I want to really show here is the threat intelligence, the CrowdStrike data. This lab is going to go into a few other things. Don't worry about those things. That's not really an important portion. The important portion here is the CrowdStrike. So let's go ahead and take a look at this. And let me go ahead and also provide a link to the help article about the threat intelligence offering, if you will. Because what we're going to be able to do in a few moments is take these various IOCs, or indicators of compromise, as they're referred to. And we're going to be able to utilize them within CrowdStrike. And so what we can do is we can take an IP address and look at it or look it up in CrowdStrike and see, does CrowdStrike think it's malicious or not? IP address is probably the most common use case, but you could do domain, you could do email address, you can do Bitcoin address, you can do all these various IOCs and have CrowdStrike tell us or tell you, is it good, is it bad? And so that's what we're going to essentially do with this lab, is utilize the CrowdStrike data. Where did my lab guide go? I lost it. Let me just open up another lab guide here. Sorry about that. All right. So in lab 8, this first portion is discussing the idea of scheduled views. Scheduled views allow you, and it's really kind of a weird portion spot for us to discuss the scheduled views. But what scheduled views allow you to do, or allow Sumo to do, is take a query and run it periodically in the background. So when you run a query, some queries might take a while to run. Some might be fast, some might be slow, and slow is relative, but they may take a while. What we can do is we can have the scheduled view or the query saved, and it's just going to run every minute. And it's going to retrieve the results every minute. And then when you want those results retrieved, you can do so. They're essentially going to be a minute delayed, but they're going to be kind of cached, or yeah, I guess cached would be a proper way to say it. So it's a helpful feature. It's not really related to security or CrowdStrike, but it's just, we've just introduced the feature in this lab. What I want to get to, though, is the query itself. And what we're showing you here, let me just see. Yeah. What we're showing you here is the idea of taking the view and looking at the scheduled view. So what we can do is we can go into manage data and go to logs. And I'll share this portion of the query in the chat as well. And I can go to scheduled views up here. And what I should have is a scheduled view called IP threats. What I'm going to do here is I'm basically just viewing this query. It's really just giving me a not a shortcut, it's actually a longer way to do it, but I'm going to grab this query. I'm going to try and grab this query. Let me go ahead and just grab it in here. And I'm going to paste it in the chat. So I want you to get this query. That's really kind of the goal of this, or the first portion of this lab. Now, it's running. I should run this kind of line by line. And so let me do that very, well, I guess not line by line. Let me do this. Let me just do a few line breaks here just to go through this. Okay, so let's go ahead and start not figuring out, but describing how this CrowdStrike operator lookup table whole thing works. So in my first line, what I'm going to do is I'm going to look through all my data. I could look through just CloudTrail data. I could look through whatever I want, but in this case, I'm going to say look through all my data. Actually, let me do that as well. So I'm looking at all the data. Basically, I'm pulling back every single log from the last 15 minutes. Now, what I want to do next is I want to start to look for IP addresses, because I want to use the IP address for this example to see, is it bad? Is it good? Does CrowdStrike think this is a bad IP address, or do they think it's a good one? And so I'm going to use this parse expression here. This parse expression is using regex, or regular expressions. Basically, it's allowing us to create a pattern that will match and will retrieve results when it matches successfully. And what this pattern is doing is looking for an IP address. It's saying, look for essentially number.number.number.number. So I'm going to run it. And so when I run line 1 and line 2, essentially what I'm left with are any log messages that have an IP address in them. Now what we're going to do is specify IP addresses that we don't want to use. Once again, this relies on public IP addresses. And so we want to say, don't show us a loopback address, or don't show us 0.0.0.0. So we're just going to exclude those essentially from our result set. Now what we're going to do is we're going to use the lookup table. Remember, a few moments ago, we looked up geographic information and we read this line from right to left. We're going to do the same thing now, except it's not geographic information. It's now security information or threat intelligence information. But we're still going to read it from right from left. So we're going to read it as we're taking our IP address, and we're taking our IP address and comparing it to a field called threats that exists within this address. This is the lookup address for the CrowdStrike data. If you remember earlier, the address for the geographic lookup was geo://location. This one is a little bit different. Now, from this data, this CrowdStrike data, we don't pull latitude and longitude. We pull things that are related to threats: actor, threat level, raw, malicious confidence. What we're doing here is we're actually renaming the field malicious confidence. So we're taking a field called threat level and calling it or renaming it malicious confidence. Now this next line is going to say, basically, only show me results that have a malicious confidence. In this case, these IPs are not showing up. They're not being detected. Essentially, CrowdStrike doesn't know about them. So what I want to do here is say, only show me those that CrowdStrike knows about. Especially for demonstration purposes right now, I just want to show you how the system works. And so now I'm starting to see that. What I see here is this IP address has a low malicious confidence. Is it safe? Maybe, maybe not. But it is going ahead and letting us know that from a high-low level, it's low. Conversely, this one is high. This is more likely to be malicious. Let's see, a couple questions. So this location, this is not a file, that's correct. It's a lookup table. How often is it updated? It's updated I want to say every 5 minutes. I feel pretty confident in that answer. The geographic information is less frequent. That might be every 24 hours. But this is, 5 minutes or maybe, I'm going to stick with that. And that's important to note. So this can change throughout the day. It's possible this is low at some point and then a hacking event occurs, maybe in your environment, maybe someplace else, and maybe tomorrow this does turn into a high. And so that is, of course, possible. The rest of this query is really just cleaning it up. So I don't want to get too bogged down into the details here, but essentially we're starting to take the actor, look at it. If it's unassigned, show it. If it's not unassigned, give it. If it has an actor, show it. If it doesn't have one, put it unassigned in there. So we're just really formatting is what the rest of this is all about. Now, let me go ahead and, because there are just a few more things in here that I do want to show. The last portion in here, so what we're left with now, because we're doing a time slice, we're doing a count, what we're left with essentially now is a time period, a user or an IP address, the confidence, and possibly the actor. So we can start to see some things here. Flip it around, see if we see some other stuff in here. So we're starting to see some actors or descriptors of maliciousness, I guess you could say. And then we're also seeing our count over here. So we're seeing our source category, where that IP address is showing up and how many times. So this IP address is showing up in our Palo Alto networks 18 times. All right, a few more steps to this lab. What I want to do next is I want to modify this query, and I want to actually finish up using our outlier operator. So what I'm going to do here is I'm going to actually remove a whole bunch of the fields. We don't need all these fields. I'll show you why we don't, but I'm basically getting in line 7, just getting rid of a whole bunch of the data. I'm not getting rid of it, just cleaning it up. Now, what I'm left with, and this is what I want to use the outlier operator for, is I'm now left with, for a 1 minute time period, remember the time slice is 1 minute, so for a 1 minute time period, a count. And so for this count, I'm going to assume or tell you this count is going to represent the amount of occurrences that CrowdStrike found, or how many IP addresses we found. And so what I want to do is I now want to start to look and determine how many is normal. Here we found 3 occurrences CrowdStrike did. Here it found 12. Is that a lot or a little? And so what I can do here is I can start to utilize my outlier operator to help me with that. So let me go ahead and count this, although I don't need that. Let me see. So what I'm now looking at is, and let me expand this out, let me get a little more data. I'm looking at now a 60-minute window. And what I now have are my counts for my time slices. So here I have a high number, here I have a low number. Basically, I want the system to now start to help me determine what is normal and what isn't. And that's what this outlier does in line 9. What we're doing is we're taking our count and we're performing the outlier operator with a bunch of math against it. And I'll talk about that math in a moment. But essentially what we're doing is we're looking at the count and we're looking at, it's going to take a moment to load. We're looking at other values and we're starting to determine what is normal or what isn't. And the system is doing that determination. So here, for example, it found 2,300 log messages. The system is telling us an acceptable range is between 1,400 and 4,300. And so that's acceptable. That's within that range. That's okay. I'm going to take this and I'm going to look at this with a line chart. The line chart is going to be a little bit more helpful for a visual, from a visual standpoint here. When I look at this line chart, what I see here is essentially everything is pretty normal. The inside here is the count. The light blue cloud is the range, and so everything is within that range, except over here. What I'm going to do is I'm going to modify this threshold. When I modify this threshold value, what it's doing is it's modifying the standard deviation that's being used to calculate this outlier, and it's going to provide me a different range, a more narrow range of what's considered acceptable. This is now finished up. And what this is now showing me is over the last 60 minutes, there actually was one period that was abnormal. In this case, it was abnormal because it was low. It was actually lower than normal. In this case, we had less than were expected, but that is still abnormal. It's still an outlier, and the system will still detect it for me. Let me know about it. The outlier operator, let me go ahead and just share the support article or help article. Provides some more detail on outlier. And so outlier is a really helpful, sorry, I didn't mean to copy what I just did in the chat. Let me just do this one more time. There we go. So what this outlier is allowing us to do, or allowing the system to do, is essentially look at traffic or look at data and determine when a normal acceptable period of time is, or when traffic is normal. You could put a static value. You could say, instead of this fancy graph and all this, I could very easily set an alert that says, show me if I go above 4,000. The problem with that is it's a static value and it doesn't grow with me. It's not dynamic. Outlier is. Outlier is looking at previous periods of time, and that's what the window represents, doing standard deviations against that data, and then displaying it to me in the form that we see down here. So the operator, the outlier operator is really helpful, really important. I don't know that I'm really giving it the full importance that it deserves right now, but really want to encourage you to use it. It's really a really helpful feature in Sumo, whether a security related or not, either way. All right, so let's see. That's going to just about conclude our lab portion. If there's questions, of course, please ask. But what we're going to do now is we're going to start to get you into the exam. And then today's not over. So let's talk about the rest of the day. What we're going to do next is we're going to get you into the exam. So you'll take that exam and hopefully pass it and do well. Then we're going to take a break for lunch. For me, it's kind of late, so I'll have a late dinner, but we'll go ahead and take a break for an hour. And so you guys can go ahead and eat. And then we're going to come back and finish up. So I believe we're going to be coming back at let's see. We are going to be getting back together at 2 p.m. local time. So we still have to take the exam. And so I want to direct you to that. But once you're done with the exam, you're welcome to certainly disconnect, or at least, either disconnect from the Zoom and come back later, either way. But then we'll pick up in about an hour, almost close to 2 hours from now. So let's go ahead and let's get into that exam. So as a reminder, we want you to take the exam as yourself. We don't want the training user getting credit for the exam. So it's important that we log out of the account. Everyone here hopefully has their own Sumo account, either a private or personal, or actually more employer account, your corporate account. And so go ahead and log in with that information. You might just be using Okta or one login, so you might not even know those credentials. But if you do, either way, go ahead and get logged in. Once you're logged in, you want to go to certification. So you want to go ahead and go to the home page. Then we want to go to certification, and we want to go to get certified. Now, this certification section, all this training and material, you have access to it forever. So as a reminder, you have access to the recorded live training. So these are sessions that I've recorded previously and you can listen to. We will also be sending you out a recording. So for our yesterday's session and today's, we'll be sending out a recording. If I'm being honest, it probably will go out over the weekend. Just we're US based, and so I think we're a little bit behind you, but it probably will go in over the weekend or maybe Monday. Or you can just always come in here and look at the training or view the recorded training. Now for today, the certification, let's get into that. So what we want to do is we want to go to get certified. We want to select the certification exam that we're interested in. Yesterday we did fundamentals, and hopefully everybody did okay, did well. Today we're going to choose the cloud security monitoring and analytics exam. So we'll go ahead and select that one. As a reminder, this exam is free for you, free for your organization. And so no charge. You'll go ahead and start the exam. And then you'll have the guidelines. And as a reminder, these guidelines are going to be the same as they were yesterday and the same as they'll be in the afternoon. It's in this case, 22 questions, 60 minutes to take it. Once again, you have access to the Sumo Logic resources. Use the documentation. And hopefully you saw yesterday during the fundamentals exam that the documentation was helpful, was insightful, and you learned something from it and through it. So please use the documentation. It's strongly encouraged, as well as Google searches and anything else you want to do. And then the pass rate for this exam is 70. You can take it multiple times. Hopefully you don't need to, of course, but if you do, that's perfectly fine. Don't be ashamed about it either. We can't, or nobody can really check to see how many times you've taken it. Technically we can, but nobody has ever really asked. So don't be ashamed if you need to take it more than once. It's fine. And then as a reminder, once you start to take the exam, come on, you'll click Start Assessment. You'll go through the exam, and then you'll click Next. And then as a reminder, you'll get your score, and then you want to click on Submit. And if you don't click on Submit, you don't get credit for the exam. I'm not going to because I don't really want to get credit for the 0, but I should click submit here. All right, so we're going to go ahead. I'm going to be quiet. I'm going to put myself on mute. I might step away for a few moments as well, but let's go ahead and start the exam. Once you're done, you're welcome to leave, and then we'll come back later for the second class, which is going to be Cloud Sim. It's going to be the same Zoom channel, so if you want to stay the whole time and or log out, log in, that's okay. So, all right, so I think we're good. I think questions were okay as well. Yeah, I think we're pretty good. So I'm going to step away. Best of luck on the exam. I hope I see you in the afternoon. That will be fun as well. And yeah, I think we're good. All right, cool. Thank you, everybody, and talk to you all shortly. And if there's questions, post them in the chat, please do, and I'll help answer them.